Okay, I think you can see what is on the board, and you can also hear my voice or my sound well. Now, yesterday we did something very comprehensive, and this is advanced management accounting for CPA, and we are doing chapter three. We are doing chapter three. We are doing chapter three. So yesterday we did a lot of discussions concerning chapter 3, and we did upload that lesson. So we are taking one more. We are taking one more question. We are taking one more question, and then we can move to something else slightly different. Now, this chapter 3, is about planning and decision making techniques whereby we have cost volume profit analysis, that is CVP, for single product and also for multiple products. The previous lessons last week, we did a calculation about how to calculate break-even point for multiple products. You have it in our YouTube. If you do not have that class, you can just get it up there. So be able to understand, as far as CVP is concerned, CVP means cost volume profit analysis, also known as break-even point. Understand limitations of break-even point, applications of break-even point. So you have it in our YouTube. You can just get that lesson there. So we completed the CVP. Now this lesson now is about decision making under environments of uncertainty and risk. The lesson that we did yesterday, which is more comprehensive and more detailed, I may not have time to go back to what we did yesterday because I already have that class in our YouTube. If you did not attend the class, you have it in our YouTube. So what we did yesterday, we did seven methods used in decision making and uncertainty. You should be able to understand in details each of these methods and how to calculate, how to make decisions based on the calculations that you have done using these different methods. Just a quick mention of these methods that you find in your syllabus as well as in your past papers are max mean method. Another one is called max method. Another one is min max regret method. Another one is expected monetary value method. Another one is expected opportunity loss method. Another one is who is method. And the other one is Laplace method. I'll just present that one so that you may see maybe the spellings if you do not have the the class that we did yesterday, but you have it in your YouTube. Just go to the YouTube, you get our class there. This class which we did yesterday, which is about the theory, the class itself about this chapter. That is these decision making. That is methods of decision making and uncertainty. We have explained the meaning of these methods and the formulas, how to make computations using them. So just you can get that class in YouTube. So what I do today, I just present briefly what to expect in that class, which you should be able to get in YouTube. And then we do one more question from December 2024, question 4B, Advanced Management Accounting. Now, if you go to our YouTube, this is what you expect. This is what we presented yesterday. We did some methods of, you can see methods of decision making and uncertainty. max mean method, max method, minimax regret method, expected monetary value method, expected opportunity loss method, who is method, and Laplace method. So we read those notes and we discussed them in details yesterday. So if you go to our class for yesterday, you see those notes there. We also did some examples, some illustrations like what you can see there. For you can see some computations there. For max mean, for max mean, for max mean is there. For max, for min max regret, you can just make a follow-up of what you have done there. You see, you're just going along the row of each item, and then you pick for max min, you pick the lowest, and for the other you take the highest. We did that discussion yesterday. I don't want to repeat that lesson. I'm just trying to present what you find in yesterday's class. For yesterday's class, that's what we expect to find there. Who is there? You can see the formula. Expected opportunity loss. Expected opportunity loss. We did that yesterday. We did that job yesterday. Okay, there is also another illustration there. Just make a follow-up. Make a follow-up of those illustrations. Then lastly, what I did yesterday, okay, can still make a follow-up from the other page. Can make a follow-up. A follow-up from the other page. Now, I think we can just move straight away to our question, which appears on the board. We just move to a solution the question as it appears on the board. So straight away, because we did the notes, we took the notes yesterday. I want us to take that example, December 2024, question 4b. Question 4b, you are told, make sure you download the past papers. You need to have the past papers with you so that you may go together. You may move together. You are told Lambda Investment Limited is a real estate firm. Recently, the company acquired a piece of land in a metropolitan area with prospective investment opportunities to develop. The investment center manager is to make a decision on which of the three mutually exclusive projects to invest in the next year. Each project is considered to be an investment center. The three investment centers are corporate offices, shopping malls, and residential estates. The projected annual payoffs per project under the three economic states of nature are as follows. You are given economic state optimistic, most likely, and pessimistic. Probability 30%, 40%, and that percent. Then corporate offices, you are given the figures there. Shopping malls, the figures are there. Residential estate, the figures are there. Required. The investment center to invest in so as to, number one, satisfy the max criterion. The max criterion. So make sure you have the class for the yesterday's class, which you have explained how to calculate or how to use all these methods. Like here, we are taught to use max criterion. And then number two, minimize the expected opportunity loss. Now maybe you do not have that question. I can present it. I can just present it. In case you do not have it, and just see what I'm saying. The question is Labda Investment Limited is a real estate firm. So I've just read the information for you. You can look at it. You can see you are given economic state, optimistic, most likely, pessimistic. Probabilities are given. Then you are given decision alternatives. Our decision alternatives comprises of corporate offices, shopping mall, then residential estate. Then you are given certain figures there. So you are told the investment center to invest in so as to one, satisfy the max criterion. 2 marks. So what to do, if you did follow what we said yesterday, max criterion, you go along each row and you identify the highest number. For example, you go along that row with optimistic, you have 100 million, 110 million, 90 billion, which is the highest. You pick 110. Go along the second row, 70, 90, 120. You pick 120. The last one, 130, 90, 70. You pick 130. So you have gone along each row. We are answering number one. The investment center to invest in so as to satisfy the max criterion. So I've said go along each row and you pick the highest number. The first row we have picked 110. The second row we have picked 120. The third row we have picked 130. Then once you have done that, you can look what you have done on the board. Check from the board. Explain from the board. Now having gone along each row, you have said you have picked the highest numbers in each row. You picked 130, you picked 110, then 120, then 130. So for corporate office, you can see it is the 130. For shopping mall, 110, and then residential estate, the highest number there is 120. In other words, even if you had to pick those numbers downwards, I believe you should arrive at the same conclusion. If you go downwards, picking the highest number, you go to corporate office, downwards, which is the highest number, 130. Shopping mall, the highest, 110. Residential estate, the highest, 120, downwards. If you pick those numbers downwards. So, because you are saying, using max criterion, you undivise, so you pick the highest. And the highest you have seen, the highest is, the maximum payoff is 130. So 130 corresponds with corporate office. So the max criterion, using the max criterion, you take 130 million, which means you should advise that particular investor to invest in corporate office. Invest in corporate office because it has the max. It maximizes then that particular payoff. It maximizes your payoff at 130. So we have answered number 1. So number 1, you're just going picking the highest number as far as those particular payoffs are concerned. So that's straightforward. Then number 2, the investment center to invest in so as to minimize the expected opportunity loss. Now, we did that one again yesterday. If you are using expected opportunity loss, you prepare opportunity loss table. You have optimistic, most likely, and pessimistic. Just the way they appear in our question. Then our probability, just as they are given, because you are given that percent, 4%, and that percent. Then you have another column whereby you pick the highest number. You go along each row, picking the highest number, and you put it there. Just like these numbers here, 130, 120, and 130. But let me show you how we have 110, 120, 130. Remember, you have a column where you are showing highest numbers. You are going along each row, pick the highest number in the first row. You put it there. Go to the second row, pick the highest number, you put it there. Go to the third row, pick the highest number, you put it there. That's the first step when you are advising based on expected opportunity loss. Okay, let me show you what I'm trying to say. I'll show you what I'm trying to say. That column with highest figures. So I've said you go along. If you go along the first row, you have 100, 110, and 90, which is the highest number there. 110, obviously. If you go along the first row, can you see where you have optimistic, that percent? So you have corporate offices, 100,000, shopping mall, 110, and then residential, 90. So you pick 110 because it is the highest. So you put your 110 here. You put your 110 here. That's your highest number there, 110. You go to the second row, you identify the highest number again. So you just go along that, you can see most likely 40%. So you look at 70 million, 90 million, and 120 million, which is the highest number there, 120. So you put 120 here. You put 120 there. And lastly, if you go along the last column, you identify the highest, the same. Identify the highest. You can see pessimistic, that percent, 130, 90, and 70. The highest is 130. 130, so you can see 130 there. So the next thing, what you do now, what you'll be doing, you'll be picking, if for example it is a first row, you'll be picking to get now these numbers there, which you have here. How do we get those numbers? This highest number you have gotten there, subtract the number which you find here. 110 minus whatever is there. 110 minus whatever is there. 110 minus whatever is there. You'll be getting these numbers. The second row, 120 minus whatever is there, minus whatever is there, minus whatever is there. 130 minus whatever is there, minus whatever is there, minus whatever is there. That's how you are getting these numbers. So you started by putting these highest numbers there, then you get this number. So how did we get 110, 0, and 20? How did we get those numbers? Let me show you. The first one is 110 million. Because 110 is the highest number there. We put 110 there. We said 110 minus 100,000. You got 10 10 million. The next will be what? The next will be 110 minus 110, which is 0. The next 110 minus 90, which is 20. You go to the second one. The highest you have, the highest is 120, so it will be 120 minus 70, which is 50. Then 120 minus 90, which is 30. Then 120 minus 120 minus 120. 120 minus 120. The last one will be 130 minus 130, which is 0. 130 minus 90, which is 40. Then 130 minus 70, which is 60. So that is how you got those numbers which appear there. Remember, you establish the first column with the highest numbers. Then you are minusing each item that you find in each cell. For example, the first one, where you have optimistic. The highest number you said is 110. 110 minus 100, you get 10. So, that is what we have done. That is what you have done here to get these numbers here. So, I'm saying, if you did not understand well, and I believe you have these post papers, you start by establishing the highest numbers here. I've shown you how to go about it. Then, if you want to get this number, you say 110 minus, this is 110 million minus 100 million. You got 110. Then this number, you say 110 million minus 110 million. You find that 110 here. 110 million minus 110 million, 0. 110 million minus 90 million, 20 million. That's how you got those numbers. Next, the highest for the second row is 120. So you say 120 million minus 70 million, you get 50 million. 120 million minus 90 million, that million. 120 million minus 120 million, you get a 0. 130 million minus 130 million, you get a 0. 130 million minus 90 million, you get 40 million. 130 million minus 70 million, 60 million. So that's how you got that opportunity loss table. That is our opportunity loss table. Now, once you have gotten that, the next thing, what you do is that you'll be just multiplying. Now, for corporate office, it will be 0. It's just this probability times, if it is for corporate office, all these numbers, you sum them together. So, for corporate office, 0.3 times 10 million plus 0.4 times 50 million plus 0.3 times 0. If you add them together, you get 23 million. That is for corporate office. You are just taking the probability times the figures for corporate office. You sum them together, you get the figure there is 23 million. That's for corporate office. You go to shopping mall, just probabilities times the figures as they appear there. So it will be 0.3. 0.3 times 0 plus 0.4 times 30 plus 0.3 times 40. You sum them together, you get 24 million. You get 24 million. Go to residential estate. 0.3 times 20 plus 0.4 times 0 plus 0.3 times 60, and then you sum them together. You sum them together, you get 24 million. So let's advise, because we are using expected opportunity loss, you pick the lowest. Which is the lowest? 23, because you have 23 million, 24 million, and 24 million. That is for corporate office, 23 million. For shopping mall, 24 million. Residential estate, 24 million. So because you are saying you are using expected opportunity loss, you pick the lowest, and the lowest is 23 million. So otherwise, pick the lowest, i.e. corporate office at shillings 23 million. So we have answered that. We have answered that. I think that is what they wanted for question 4b. Now I go now to question 4c. You can check that from the board. Check from the board. If you have any question, you can ask. Any question? If there is any clarification that you need, or maybe any mistake that you may have made, you can mention it. Not necessarily right now, but in the YouTube, you can pinpoint anything that has not been done the right way. But I believe what you have done is okay. But you see, nobody is perfect. If there is anything that you have not done the right way, you can mention right now, or you just mention that in the YouTube. You can just mention in our YouTube. Okay. I think that's okay. I want us to take another question. I want us to take a different question, and that is number B. You have the papers, you can read number 4B. 4B. Remember, it is December 2024. Question 4B. 4B we have done. Now we want 4C. The same question, but part C. Advanced Management Accounting, December 2024. 4C. We have done number 4B. Now that paper, remember we also did question 4A. 4A is about break-even point with multiple products. That question which you can see there, question 4A, Angrofed Group. If you have this paper, we have also done solution for that. This in our YouTube. You can find it in our YouTube. 4A, December 2024, question 4A. We have done that. We have uploaded in our YouTube. You can get it there if you did not attend the class. So question 4A has been done. Now we are doing question 4B. So question 4A was about break-even point. That is cost, volume, profit analysis. We have done that one. And this question is for multiple products. It has been done. The solution is with you in the YouTube for those who are following. Now we are doing number 4B. And we have done 4B. 4B. We have done 4B. Now I want us to take 4C. We are taking 4C now. Let me read it for you before I project it. 4C. So you're told Labda Investment Limited is contemplating acquiring perfect information from an investment research firm about the viability of the investment opportunities. The investment research firm is willing to provide perfect information about the investment project at a cost of shillings 30 million required. Using suitable computations, advise Labda Investment Limited on whether or not to acquire the perfect information from the investment research firm. Using suitable computations, advise Labda Investment Limited on whether or not to acquire the perfect information from the investment research firm. I can present that one to you. Maybe you need that. Okay. We are told Labda Investment Limited is contemplating acquiring perfect information from an investment research firm about the viability of the investment opportunities. The investment research firm is willing to provide perfect information about the investment project at a cost of shillings 30 million using suitable computations and advise Labda Investment Limited on whether or not to acquire the perfect information from the investment research firm. The question is there. Number C is there. Okay, let's do it together. So what we do is that because you have the table, I just want you to look at the table as it appears there. So what you'll be doing, you look at the table as it appears there. You're using the same information. So what you'll be doing, for example, for corporate office, you take 0.3, that is that percent, 0.3 times 100 million plus 0.4 times 70 million plus 0.3 times 130. You're just multiplying the probability with those decision alternatives downwards. You sum them together. I've given you the example for corporate office. 0.3 times 100, 0.3 times 100, 0.3 times 100, then you plus 0.4 times 70, then you plus 0.3 times 130. For shopping mall, 0.3 times 110 plus 0.4 times 90 plus 0.3 times 90. For residential, 0.3 times 90, 0.3 times 90 plus 0.4 times 120 times what? 0.3 times 70. You add them together. You add those figures together. So you're using that table. This is how you are. This is what I'm talking about. The solution is it legible? Let me see whether it is legible. It's legible, so you are able to see what we are doing. And we're just using the first table as given. We're just using that table. The table as it appears there, you're just picking probability times what? Those figures in shillings in each decision alternative. You multiply the probability by the shillings, then you plus. That's what I'm saying. You can see as it appears there. You can see as it appears. So here, I've told you, for corporate office, you take 0.3 times 100 plus 0.4 times 70 plus 0.3 times 130. You get 97,000 or million, whatever the figures are. Then for shopping mall, 0.3 times 110 plus 0.4 times 90 plus 0.3 times 90, we got 96 million. For residential estate, 0.3 times 90 plus 0.4 times 120 plus 0.3 times 70, we got 96 million. We got 96 million. So we are using, now this is called expected monetary value. This what you get here. If you are to pick, in this case you are to pick the highest, that figure you have picked there is the expected monetary value without perfect information. Without. So the first one you got, that is for corporate office, you have gotten 97,000. For shopping mall, 96,000. And for residential estate, 96,000. Pick the highest. The highest is 97,000. So pick the highest, which is a corporate office. So that is expected monetary value without perfect information. Now, I want us to can read that. Expected monetary value with perfect information is given by, what's the first step that we should take? Summation of probability times highest values. Expected monetary value with perfect information will be given by, take the probability and you multiply by the highest values. You can see the highest values we have is 110, 120, and 130. If you look at our table, you should be able to establish that the highest values, I think we started with the max criterion. That's where the question had started. So, because we are using the same question, the highest values you can see is 130. Then we also have 120 and 110. So we are just multiplying this way. We are multiplying this way. We have our probabilities there. So we are saying expected monetary value with perfect information is given by summation of probability times highest values. So you multiply by each highest value. For example, you have said 0.3 times 110. 0.3 times 110. If you go along that particular row, you have 100, 110, 90. The highest number there is 110. So 0.3 or that percent times 110 plus, you go along the second row, the highest number there is, we have 70, 90, 120. The highest number there is 120. So 0.4 times 120. Then you plus what? The last row, 0.3 times, which is the highest number, 130, 90, and 70 is 130. So 0.3 times 130. So what you do is, you just pick 0.3 times 110 plus 0.4 times 120 plus 0.3 times 130. So that is what we are saying. It is on the board. You should be able to see it on the board. You have done it here. Expected monetary value with perfect information, summation of probability times highest values, 0.3 times 110 plus 0.4 times 120 plus 0.3 times 130. You sum up, you get 120,000. Then lastly, value of perfect information is given by expected monetary value with perfect information minus expected monetary value without perfect information. Remember this 97 that we got here, where we started. This expected monetary value without perfect information, this 97 that you got there, is the expected monetary value without perfect information. So, what is the 120 here? This 120,000 is the expected monetary value with perfect information. So just pick, as you can see what I've mentioned there, is that value of perfect information is given by expected monetary value with perfect information minus expected monetary value without perfect information. So my expected monetary value with perfect information is 120,000, and Expected monetary value without perfect information is 97. So I just take 120 minus 97, I get 23,000. Now 23,000 is a value of perfect information. But that is not the end of that question because they are asking us. Now let's refresh that question. Lambda Investment Limited is contemplating acquiring perfect information from an investment research firm about the viability of the investment opportunities. The investment research firm is willing to provide perfect information about the investment project at a cost of shillings 30 million required using suitable computations and advise Lambda Investment Limited on whether or not to acquire the perfect information from the investment research firm. Now, this is the point that you should note here. We are told the investment research firm is willing to provide perfect information about the investment project at a cost of shillings 30, that million. So, that million is a cost of getting perfect information. Cost of getting perfect information. So, if this firm approaches a research firm to provide perfect information, then that particular research firm will charge that million. But the value of perfect information as per our computations is 23 million. So what are we supposed to do in that case? If the research firm is charging us that million, but our value of perfect information is 23 million. So you can see what I've said is that the cost of getting perfect information is that million, but the value of perfect information is 23 million. So what is the advice? Reject the perfect information. Reject. In other words, you don't need to go for this perfect information from the research firm. It's expensive. In other words, they have overcharged you. Does not make sense. You should not go for that perfect information from the research firm, and that's the reason. That's the conclusion for that. So that is it for that. I think that's enough for that particular question. I think you can see everything very clear. I think everything is quite clear. So I want to remind you again before we go to something else, before we move to something else, you should be able to see this figure here. You know where 23,000 is coming from. Was 120 minus 97 is 23. Value of perfect information. Now, before we conclude, I've said that this chapter is about methods of decision making under uncertainty, and these methods are max-min method, max-max method, min-max regret method, expected monetary value method, expected opportunity loss method, Who's method, and Laplace method. So these methods, we discussed them last lesson, as I have said by the start of this lesson, and we have them in our YouTube. Again, you can still get these methods in quantitative analysis, but here we have discussed them comprehensively. You don't need to go back to quantitative analysis because whatever you find in quantitative analysis is the same discussion that we have explained here. So that was December 2024, question 4B, and also 4C. You've done it together, and you have explained what you were required to do. So again, we appreciate those who are becoming our new subscribers. So continue being part of us. There are those who are liking the video. There are those who are making comments. There are those who are calling us through our numbers. Just continue calling us, asking questions, making inquiries. I'll give you our numbers, and most of you have our numbers. Try to subscribe if you are not subscribed, because you are waiting for the examination by the first week of December 2025. The first week of December 2025, that is when, especially the KASNEB, the Kenya Accountants and Secretaries National Examination Board, the exams will start first week of December this year, 2025. So I've been advising that you subscribe so that you may move together. Even if you are studying from other institutions or you are studying for yourself, so that whenever we have a lesson, whenever we upload a lesson in our YouTube, you are able to access. You are able to be updated. You get updates the shortest time possible, so that you make a follow up of what we are doing and compare with what you are doing wherever you are, and you can make comparisons. You can also compare us with other tutorials in the YouTube from the Kenyans themselves, and also from those who are doing it from other countries like Nigeria, Ghana, Europe, United States, and other countries. You compare, and then you be assisted. You have access to a lot of information. So kindly subscribe, just be following what we are doing, and then I think this information will help you. We are still publishers. We write books for CPA, that is Certified Public Accountants, for ATD, Accounting Technician Diploma, and for CIFA, that is CIFA, Certified Investments and Financial Analysts. So if you need those materials, you can just call us again. I'll give you my number. You make inquiries. We also offer online classes. We still have physical classes. We are based in Thika Town. Thika Town is not very far from Nairobi. So you need physical classes, you can just call us. You are based in Thika. If maybe you are very committed, you are very busy, or because of distance, maybe you are very far, maybe you are not within Kenya, but you still need our assistance, I'll give you my contacts or my number so that we can assist you as your needs may arise. Okay, our numbers will be here, plus 254. That's the code for Kenya, the Kenya's code. This is a code for Kenya. So if you are not within Kenyan boundaries, you start with plus 254 727 87 10 93. These are our contacts. If you are within Kenyan boundaries, you just start with 07 27 87 10 93. 1093. So that's, I think, everything is in order. I think you have understood what we have done here. You just need to understand what we told last lesson. And again, I advise you that you have these books which we do publish. They can still help you. match. So lastly, I present these methods which you are supposed to know in details. These methods, make sure you know them in details. You can see methods of decision making and uncertainty. That is what is covered. Understand max-min method, max-max method, mini-max regret method, expected monetary value method, expected opportunity loss method, and Whois method, and Laplace method. Laplace method. Now let me mention something about Laplace method before I leave, even though I think I mentioned that last time. Laplace. Laplace method. Laplace method, usually you use it in those situations where probabilities have not been provided. For example, here in this question, you can see we are given probability 0.3, 0.4, 0.3. So in any event, if probability has not been provided, we assume that all these events which we have, all the items that we are dealing with, have equal weights. We are apportion them equal weights. So if, for example, here in this question there was no probability, it means we should have used a Laplace method. What you could have said, we could have used this one as what? Zero. This we could have said 1 over 3. This could be 1 over 3. And this could be 1 over 3. Laplace. That's what we mean by Laplace. So if you are given a question and probabilities have not been given, you assume that all these items are what? Equal weights. If there are 4 items, it means 1 over 4, 1 over 4, 1 over 4, 1 over 4. If there are 2 items, 1 over 2, 1 over 2. So in that case, you'll be using what? Laplace. That's what we mean by Laplace. Laplace. Apportionment is based on the assumption that those items have equal weights. Here, the question that we have done, the probabilities have been given. If they have not been given, we always assume they have equal weights. And in that case, we'll be talking about Laplace. Laplace. Now, lastly, as I just did last time, I gave some questions from this booklet to go and, but before that, I want to give you the meaning of perfect information and imperfect information. Now, perfect information, I've seen somewhere here we are saying expected monetary value with perfect information, expected monetary value without perfect information, and the like. So let me mention what perfect information is. Now listen to this. Perfect information is available when we can make an accurate prediction about the future with 100% prediction. However, the concept of perfect information in real world does not exist, and so it may be viewed as just an imagination of the mind. For instance, we may predict the future profitability with a reliability of 90%. Thus, our value of imperfect information will be less than the value of the perfect information, unless both are 0. One can obtain information from various sources such as market surveys, use of consultants, conducting pilot tests, etc. Information can be categorized based on how reliable it is likely to be for predicting what would happen in the future and for making the managers to make better decisions. If information can be guaranteed to predict the future with 100% accuracy, it will be called perfect information. Even though, as mentioned earlier, there cannot be perfect information in the real world situation. Both the perfect and the imperfect information is costly and their respective values must be established. The expected value of perfect information as used in decision theory is the price that one would be willing to pay so as to be able to get information. The value of perfect information is given by expected monetary value with perfect information minus expected monetary value without perfect information. We have done it here. So that is perfect information. Now let's mention something about imperfect information. This is occasioned by the fact that the market research findings or information from the market studies may be reasonably accurate, but still being wrong in prediction, hence providing imperfect information. Expected value is the total weighted outcomes or payoffs that is associated with a decision. The weights will always reflect the probabilities of the alternative events that produce the possible payoff. Mathematically, it is expressed as the product of an event's probability of occurrence and the gain or loss that will arise therefrom. Where there is a range of possible outcomes and a variety of possible responses, a payoff table is a useful way to represent a scenario. A payoff table illustrates all the possible outcomes, such as the profit or loss, hence it is used in decision making under uncertainty. Okay, that's something that I just wanted to read for you concerning what is perfect information and what is imperfect information. Now let me present it to you. You can just pause your video and you read it from there. To be of much help, the meaning you can read from the top. Value of information in decision making. Value of information in decision making, especially perfect information. Perfect information. You can read perfect information. Then I move to the next page. Okay, I'll move to the next page. That is continuation from the previous page. And then just imperfect information. Imperfect information. So compare perfect information with imperfect information. Then lastly, I gave some questions from quantitative analysis which can help you. You can use these questions as part of your exercises. Those questions there are questions there which you can use. Use those questions for your revision. Those are good questions for your revision. Also, on the other side, you can also check from the other side if there are other questions you can use to practice. can use to practice. Now lastly, I remind you about these methods and their computations. I'll give you some examples by the start. Just to remind you, those examples you can see for who is the formula that you use. Alpha times maximum plus 1 minus alpha times minimum. Illustration is there. The first illustration is for max min. You can see how you are going along each row. If it is for max min, go along each row identifying the lowest. For example, the first one you took negative 100, second one negative 20, third one negative 260. If it is max, you go along each row taking the highest. The first row you took plus 8, second row plus 120, third row plus 160. Now you are using min-max regret. I told you, you just go along each column, take the highest number, then you minus whatever number is in each cell. For example, for boom, you take 160. 160 is the highest number there. So you take 160 minus 8, 160 minus 20, 160 minus 160. For steady state, remember this is minimum, the min-max regret. The highest number is 60, 60 minus 10, 60 minus 60, 60 minus 0. Okay, recession, the highest number there is plus 120, 120 minus 100, 120 minus 120, 120 minus 160, 260 that is. So that kind of table that you get from the other side will look something like that. You can see what you get. 80, 180, 0, 50, 0, 60, 220, 0, 380. Then you have the last column there, minimum regret. You pick the highest number in each row. Pick the highest number in each row. Another illustration is there. Another illustration. You find it there. Another illustration for max min, max, min max regret, who is. Then expected opportunity loss method. You can look at it from the other side and check from the other side what we have done. You can check what we have done. Illustration. Compute the expected opportunity loss using the below given information. Solutions are there. Another illustration is there. A manager has a choice between two contracts. The illustration is there. It goes all the way through the other side. The illustrations are there. Max mean method is there. Can move to the other side. I think it continues from the other side. It continues on the other side. There is a continuation there. Min-max regret method. Laplace method is a Laplace. I've told you, probabilities are not given. You assume they have equal weights. You can see that particular column for probability. We have used 1 over 3, 1 over 3, 1 over 3. These are illustrations from our book. Those are illustrations from our book. Continues all the way. And that is enough for that. So, well, I think we have done enough discussion for that. I think we should stop at that because we have done another class. We did previous class last time. We have this in our YouTube. You check what we did last time, compare with what we have done today. You also compare with what you are doing in the college where you are studying from, or if you are studying you are studying for yourself. Compare what you have done here, and then try to evaluate yourself. See whether you are able to attempt these kind of questions that you answer on your own. If you need any question to be attempted and uploaded in our YouTube, you can just call us. Our number is there, and then we can help you. Remember, you subscribe in our YouTube so that you may be getting updates as and when we upload new lessons. So thank you for being with us. Continue being with us for more lessons. Remember, we are still having advanced financial reporting and advanced financial management, advanced taxation, advanced auditing and assurance, all CPA lessons from foundation, intermediate to advanced level, CIFA, that is Certified Investments and Financial Analysis, foundation, intermediate, and advanced, ATD, that is Accounting Technician Diploma. We still have the practicals, that is Business Data Analytics for CPN, as well as Financial Modeling and Data Analytics for CIFA. So all these materials, you can get them anytime you want through our contacts. So let's stop at that for today. We continue tomorrow.